Welcome to the Complete Docker course, where you are going to learn all about running containers using Docker and Docker Compose. So if you want to take your DevOps skills to the next level and stand out as a software engineer, or if you want to boost your career prospects by becoming a DevOps engineer, then this is the course for you. We will start this course by learning what Docker is and the problems that it solves. Then we are going to move on to Dockerizing and deploying our very own multi-container microservices setup using Docker Compose. And by the end of the course, you will have a fully deployed microservices app powered by Docker, and you will have learned the Docker skills that are needed to take your DevOps skills to the next level. My name's Chris, and I have been a software engineer for over 8 years. I'm super excited to go on this adventure with you into the world of Docker, so let's get started. So what exactly is Docker? The quick explanation is that it simplifies the building and deployment of apps using lightweight containers. So before we get into the finer details of what this means, let's look at the problems that Docker solves. So if you pretend that you are a new developer who is starting in a new company and you're setting up your development environment for the first time, you could have 2 or 3 microservices that you have to run. There could be a reverse proxy or a load balancer that you need to set up, and there could be a database to install along with a Redis cache and so on. So trying to install all these things is pretty time consuming. We have to go and we have to get the installation files for our operating system and install everything individually. And the other drawback here is that we could end up with a different version of the software compared to the other developers in our team. And there could be some subtle differences between the running of the software on different operating systems, which might cause strange side effects when everything is trying to work together. So Docker simplifies the setup by containerizing each component, ensuring consistent environments, and eliminating manual installations and any version conflicts that we might come across. So Docker solves a similar problem when we try to deploy our code to different environments. If you're an experienced software developer, you might have had situations where the code works on your local environment, but when the code is deployed, it doesn't work as expected, leading to the infamous "it works on my machine" saying. So this can be for any number of reasons, such as different operating systems, different runtimes versions, different configs, and so on. So since Docker containers are self-isolated and are packaged with all the things needed to make the app run, it makes it much easier to ensure that the app works regardless of the environments, and we avoid situations where we encounter errors in our staging and production environments because they are so different to our development environments. Okay, so just a quick note on Docker versus virtual machines. So virtual machines could solve the same problems that we just talked about, but the drawback is that virtual machines are quite expensive to set up in terms of the resources that the machine uses compared to Docker containers. So on the left, we have a Docker setup. So Docker uses containers to run the applications, and it shares resources on the host, such as the kernel, to make the containers lightweight. So this is unlike VMs, which have to include a full copy of the operating system on each instance, which means whenever we start a virtual machine that's running one of our services, it has to go and install and set up an entire operating system on each one of our services. So this can take quite long, and it just makes things a bit efficient, as opposed to Docker containers, which only have the app source code and the runtime and dependencies and so on, and then it shares the operating system on the host machine. Okay, so how does Docker actually work? The first step is that we develop our app as usual. So this is done on your local development machine using your favorite tech stack. So how does Docker work then? Okay, so how does Docker actually work? So the first step is we develop our apps on our development machine as we normally would, using your favorite IDE, tech stack, and language. In this example, we're going to be building a Node app, so the source code is going to be in JavaScript, and then the runtime is going to be the node.js runtime. And then we could have some other config and dependencies, such as environment files and settings and so on. So all this stuff runs on our local development machine. And when it comes time to put all this stuff into a Docker container, the first thing we need to do is create what's called a Docker image. So an image is an artifact, and this artifact contains all the source code. It contains the runtime and any config that's needed to run our application inside a container. You can think of a Docker image as a blueprint, which is used to create containers that will actually start and run your application. So the Docker image itself doesn't start the app. It only has all the code and dependencies that it needs to run. So once we have an image, we upload the image to a Docker image repository, which is where the images are stored, managed, and distributed from. So this is usually stored on the cloud, and there are many providers who we can store containers with. So for example, there's dockerhub, AWS has their own ECR, and Microsoft have their own thing as well. So they all do the same thing, and that's basically let us store our Docker images. So you can think of the Docker image registry as a GitHub for Docker images. So the Docker image registry that we use is usually hosted on the cloud, which makes it possible to deploy anywhere, as we'll see later. But Docker also provides a local image registry on your own development machine where we can build and store our image locally within the Docker context. So this just makes it easier and faster to test and work with containers on our development machines without the overhead of having to add an external image to the cloud repository and pull that image down and so on. Once we have an image created, either on our local Docker context or in a cloud hosted registry, such as dockerhub, we can pull the image down and start a Docker container based on this image. So this is an important step, as this is how we deploy and run the containers in a CI/CD pipeline, which we will see later. So when we pull and run a Docker image to start a container, we can run it anywhere that has Docker installed, such as the local development machines or any cloud servers that have Docker installed on them. So this can be AWS, Azure, or even Google Cloud, or any other provider. Okay, so just a few more notes on containers. When a container is deleted, its data is gone. So for example, if you have a container and you create a file inside it, when that container is deleted, that file will be deleted as well. This is the same with database containers. If you delete the container, it will destroy all the data that was saved into the database. So we will look at how to preserve data using what's called persistent volumes when we look at the real life examples. So containers will also run in their own isolated environment. This means by default, we cannot directly access the app inside a container unless we expose it manually, a network using what's called port binding. So again, we'll see how this works when we look at the real life examples. And Docker gives us a CLI, which makes it easy to create images, start containers, and so on, using some straightforward commands. And these commands work the same regardless of the environment. So they're going to work the same on our local dev as they do on any cloud service that's running our Docker containers. Okay, so now we'll look at some practical examples. Before we jump into this, we'll have a look at the architecture of how our app is going to work and the containers that we're going to set up. So this will be an example of some architecture that you might see in a production environment, which we will build today. So for this example, you can assume we're building a library API that helps us manage all the books in our library and helps us to see which books have been checked out and so on. So we will have two microservices. We'll have a book service and we'll have a loan service. So the book service up here is going to be responsible for displaying and returning the available books. This book service will store the books in its own database, which in this case, we're just going to use MongoDB, which is going to run in its own container. And this MongoDB database is going to persist its data in persistent volume. So a persistent volume is just a static file that lives on the host that this container will read every time it starts up to get any saved data. So this is how the data is persisted between when a container is destroyed and restarted. Okay, so that's our book service. Down here, we're going to have a loan service, and this is going to be responsible for returning the details about the loaned out books. So the loan service could have its own database as well, but we're going to leave that out for this example. So the loan service will also make a call to the book service if it needs to get the full book details. And over here on the left, we also have an Nginx container. So this is going to act as a reverse proxy, which directs traffic to our services, which is a typical thing you'll find in this sort of microservice setup. Okay, so one of the biggest advantages of this setup is that we can deploy the book service, for example, without affecting any other service. And Docker will do some clever stuff here to make sure that the new book service container has started before it destroys the old container. So this approach helps us guarantee uptime. And likewise, if one of our services encounters an error or an issue and goes down, so for example, if the loan service suddenly stops working, then the other containers up here aren't affected, and it means that some of our app will still work. So the user will still be able to go and do certain things while we are fixing our loan service problem that caused it to stop. Okay, so don't worry if this seems a bit overwhelming. We will build it out step by step and explain more things in detail as we go throughout the course. And if you want to reference this diagram at any point as we build out the different bits and pieces, You can find this diagram in the repo, so just check the links in the description to get that. Okay, so for the practical examples source code, I've included the full repo in the description, and there's also starter files for each chapter. So if you're planning to use this course as a reference, you can jump to the chapter that you need using the timestamps on the video, and you can find the starter files for that chapter on its own GitHub branch. So the only thing you really need to follow along with the practical examples is you'll need to have node.js installed, as we're building out a node.js app, and you'll need a Unix-based command line as well, as the commands that I'll be using are going to be in that format. You'll also need your own ID and things like that. I do recommend Visual Studio Code just so it's easier for you to follow along. And at the very end, we're going to deploy our app to DigitalOcean. I just like DigitalOcean as it's quite easy to get a server set up quite quickly. It does cost a few dollars per month to run the server, but if you check the link in the description, you should get some free credits, which is more than enough for you to run this example for free, just to see how it all works. So check the link in the descriptions to get that. Okay, so before we get into the code and start to build out some of these microservices, there's a few things that we need to set up. So the first thing you want to do, if you're following along, is you want to go to docker.com, and then if you go to products and if you choose Docker desktop from the menu, it will bring you to the Docker desktop page. So what this does is it lets us install Docker onto our own development machines, and it gives us a nice UI that we can use to see our containers and our images and things like that. So from here, what you want to do is choose the appropriate download for your system. So once you've done that, to test that it's working, what you can do is open up a command window or a terminal, and in here, if you type docker -v, just like this, and hit enter, it will give you the version of Docker that you're currently on. So this shows that Docker is installed and that it's working. Okay, so once you have Docker installed, the next thing that you want to do, if you're planning to follow along, is to go to the GitHub repo for the starter files. So you can find the link for this in the description. And what this is the repository for the code that we will need for the different parts of the practical examples. If you go to the branches over here, you can see there's a different branch for each part. So as we go through, I'll ask you to check out the appropriate branch for the part that we're on. So this just gives you the starter code for the different bits and pieces that we need to run the app, so that we can focus completely on all the Docker aspects without having to worry too much about writing the code from scratch. So to clone the repo, what you want to do is go to the code section here, and depending on how your environment is set up, you can choose HTTPS or SSH to check out the repo. And once you've checked out the repo, go ahead and open up the code in Visual Studio or an IDE of your choice. Doesn't really matter too much, whatever you're comfortable with. And here you should see all the code for the finished version of the app. So if at any point you're finding that things aren't working, if you check out the main branch and have a look at the finished examples, hopefully it will get you over any blockers that you hit. Okay, so the last thing we need to do before we can jump into the practical examples is we want to check out the branch that has the starter code for part 1. So if you open up a terminal again, and just make sure that you're inside the repository for your source code, and then we'll just do git checkout part 1. And as you can see now on the Explorer on the left here, we have a book service, and we also have a getIgnore file. So this is the first little microservice that we're going to build, and we'll just have a quick look at the code to familiarize ourselves with it. So open up book service, and if you go to source, you will find an index.js file. So open this up, and all this is a basic Node and Express app. So in here, we just specify the Express server. We specify the port that it's going to run on. So the service is going to run on port 3000. And then down here, we've just specified an array of books. So each book has an ID, a title, and an author. And if we scroll down again, you can see we have a get request to /books, which will return this array of books for us as a JSON object in the response. So what we can do is start this to make sure that it's working. So again, open up a terminal, and here we're just going to make sure that we're in the book service directory. So say cd book service, just like this, and hit enter. And then in here we'll do npm i, and this will just install all the dependencies that the project needs, which isn't too much. It's just all the Express stuff really. And then from here we can say npm start. So this will do is it's going to start up our Express server. So go ahead and hit enter, and all being well, you should see a message that says the book service running at localhost 3000. So, and just to make sure that the get request is working, what we can do is open a new terminal. So we'll keep this terminal and the app running. And in the other terminal, we'll do curl, and then we'll do http ://localhost, add a colon, and then we'll say 3000, which is the port that it runs on, and then we'll say slash, and then we'll say books. And then if you hit enter, you can see that it's returned the books from the array that we have in our index.js file. So if you have got this far, that means that the app's working. And the next step that we will do is we will dockerize the app. So there's a few steps that we need to do. And the first one is we need to create a Dockerfile. Okay, so now that we have Docker installed, the first thing we're going to do is we're going to create a Docker image from our source code. So a Docker image is a lightweight, standalone, executable package that contains everything we need to run the app. And we create an image using a Dockerfile. So on the right, we have an example of what a Dockerfile looks like. And it's basically a set of instructions or commands in a file that is used by Docker to create the image. So once an image is created, it can't be changed, so they're immutable. So every time we make changes to our code, we have to create a new image from that code. So we can't go and change an existing image, as that's not how Docker works. And the image itself does not start and run the app. It merely contains the instructions on how to do that. So again, you can think of images like blueprints that are used to create containers, and a container is where the app actually runs. And inside the book service, we're going to create a new file, and then we're going to call this Dockerfile, just like this. So if you're in Visual Studio Code, you'll probably notice that the little icon for the Dockerfile has turned into the Docker icon. So this is a convention. So by naming this Dockerfile, when we run certain Docker commands inside our book service, it will know to go and look for this file. So we'll see an example for this in a second. But first we need to create our Dockerfile. So in here, the first thing we'll say is we'll say from, and then we'll say node:20. So because we are creating a Node and Express app, we want to tell Docker to use the existing Node base image as its runtime. So for example, if you needed to Dockerize a Java and Spring Boot application, for example, then this might be the Java runtime or the Java development kit. So there's a bunch of different runtimes that you can use depending on your requirements for your app. Okay, so now that we've specified the runtime and the base image to use, we can then specify the working directory. So say work, and then we'll say dir, all one word, and then we'll say slash, and then we'll say app. So this specifies the working directory where all our files will be copied to or added to, and where all the commands will run. So inside our Docker container, all our stuff is going to be under the /app folder. So now that we've created a folder, what we can do is start copying some of our files from the directory in here into our Docker image. So we can specify a command in our Docker file. So in here, we can say copy, and then we'll say package star or *.json. Then we'll add a space, and then we'll say /. So what this is going to do is it's going to copy the package.json file and the package lock file from our source code into the working directory of our Docker image. So in other words, it's going to copy it to /app, and it's going to copy it to the top level here. So because we specified the working directory up here, this is always going to be the relative path to the working directory. So in other words, the top level. Okay, so once we've copied our package.json over, what we can do now is install the dependencies. So we can say run, and then we'll say npm install. So this is going to execute within the app folder or the app working directory, and it's going to install all the dependencies that are specified in our package.json. Okay, so now once we've installed all the dependencies, what we can do is copy our source code over. So we can say copy, then we'll say dot, add a space, and then add a dot again. So this is going to copy all the files from our book service directory into the Docker image and put everything in the same structure as we have it here underneath the /app folder. So the reason we have to do this is because we want to copy all of the source code, any static assets that you might have in here, and things like that. So there are things that we do not want to copy, such as the node modules, because those are going to be added at build time whenever we install the app. So we'll see how we can fix this shortly. But for now, we'll just finish adding in our Docker file. So after we've copied all the source files and we've added our dependencies, the last step is to add a command that starts our app. So we'll add a new line in here, and then we'll say cmd. So this means execute a command. and then we'll add an array. And in here we'll add a string, and then we'll say node. Then we'll add a comma just outside of the string, and then we'll add a string again, and then we'll say /src/index.js, just like this. So what this is going to do is it's going to go to the index.js file in the source folder, which is in the app folder up here. And then it's just going to use node to start the index.js file. And because we're using the node base image, we don't have to do anything in here to install node or anything like that. So it's all packaged nicely for us. And because we specified a version 20 up here, then anyone who starts a container based on this image is always going to have the same version of node. Okay, cool. Okay, so now that we have a Docker file, the next step is to build an image based on this Docker file, and then from there we can start a bunch of containers. Okay, so before we start building our images, what we want to do is tell Docker to ignore some of the files when it runs this Docker file. So to do this, we go into the Explorer, and under the book service, we're going to add a new file, and this is going to be called .docker-ignore. So all one word, and keep an eye on the dot at the start, and then just hit enter, and this will create this file for you. So again, if you're in Visual Studio Code, you can see that the icon has turned into a little Docker icon. So again, this is a convention. And in here, we can specify all the things that we do not want Docker to copy to our image. So in here, all we want to do is say node_modules, just like this, and this will ignore the huge node modules folder. Okay, so now we will build our first image based on our Docker file. So to do this, what we'll do is open up a terminal, and inside the terminal, what you want to do is do cd service just to make sure we're in the book service. And from here, what we'll do is we'll say docker space build space -t, then we'll say book -service, then we'll add a colon, and then we'll say latest, and add a space again, and then we'll add a dot. So what this will do, is it's going to build an image called book service, and it's going to tag it with the tag latest, which is what the -t flag means. It means that we want to tag our image. And then the dot at the very end is important because it tells the docker build command to look in the current directory for a Docker file. So in this case, it's the book service. So if we open Explorer, it's going to, since we're in the book service folder, it'll automatically try and find this Docker file, and that is the one that it will use to build an image. Okay, so before we try to run this, you want to make sure that you have Docker Desktop started, as this is going to start the Docker context on your local environment as well. Okay, so once you have Docker Desktop started, go ahead and run this command. So hit enter, and as you can see, there's a bunch of stuff happening. So we'll scroll up and have a look, and you can see that the Docker build stuff is giving us some logs here. So it's found the Docker file, and if we scroll down, it's also found our docker-ignore file. And if we scroll down some more, you can see it's running all the commands that we added to the Docker file. So, and it's pulled in the node runtime, it's created the working directory, it's copied all our stuff, and then it's done npm install. And usually, if we encounter any errors during the build image process, they will be displayed here. So because we didn't see any errors, we can assume that it worked. So if you scroll down back to your command line, what we can do is run a Docker command that will show us all the images on our Docker context. So we can say Docker, then we'll say Docker space image space ls. And as you can see here, we have the results of our command. So we have an image called book service, and we've tagged it with latest tag, and it gives us an image ID and the time that it was created. Okay, so now we have a Docker image, and if you prefer, you can also go into Docker Desktop, and on the left, if you choose images, you can also see some stuff around the images that you have in the Docker context and any containers and things like that. So if you prefer to see things a bit more visually, then feel free to jump into this. I personally prefer the command line because you tend to use it a bit more in production environments when interacting with like different CLIs and things. So I'm going to be using the terminal for most of this tutorial, but you can feel free to go ahead and use Docker Desktop if you prefer. So we'll jump back into the code from here. And now that we have an image, what we can do is create a Docker container based on this image. So an image is just a file or an artifact that acts as a blueprint, but it doesn't do anything by itself. So the image itself doesn't have any code running. It just has all the source code and all the files and the runtime that it needs to start. So whenever we run a container, that is the process of actually starting up our app, which is what we'll do now. Okay, so now we have created a Docker image. What we'll do is learn how to create a Docker container from this image. So containers are always created from images. There's no other way for us to create a Docker container. We can start many containers from the same image with different options and environment variables if necessary. So this is one of the benefits of why we keep images and containers separate. And Docker provides some simple commands to start and interact with our container. So we've seen an example of some of the commands that we needed to build a Docker image. And here's an example of the run command that we will use to start a container from an image. So I'll explain what this command does, what these flags and things mean in this section. Okay, so to run our Docker image in the command line, what we'll do is say docker run, then we'll do -d, and then we'll do --name, and then we'll say book-service, add a space, and then we'll say book-service again. So this is going to start a Docker container in detached mode. So that's what this -d flag is. And it basically means that when we start this command, it's going to start it in the background as opposed to starting the container in this actual terminal, because what would happen in that case is that if we stop the terminal, then the container would stop as well. And then we're giving the container a name. So we're just calling it book service. So sometimes Docker will add a random string or a random phrase as the Docker container if you don't specify a name. And the last argument here is the name of the image that we want to start this container based on. So in this case, it is the book service. Okay, so now what you want to do is you want to hit enter. And again, just make sure you have Docker desktop running so that the Docker daemon and the Docker contexts are all started. And if all went to plan, then you can see that we have this long string. So this is the ID of the container that Docker has started for us. So now what we can do is say docker container ls, and this will display the running containers that we have. So as you can see here, we have the container ID. It's got the name of the image that it used to start the container, and then it's got the created time and the status, and then it's also got the name. And here we've called it book service, just so we know that this is based on the book service image. Okay, cool. So now that we have a running container, how do we access it? So by default, containers are isolated environments. So in here, you'll probably notice that the ports field is empty. This means that the host, or in other words, this terminal on our own development machine, cannot access this container. So what we have to do in order to access our app and be able to do GET requests to the books endpoint is we need to expose a port on the container. So again, this is done in Docker commands. So what we can do is stop the container that we just started. So in here, we can say docker stop, and then the name of the container that we want to stop. In this case, we'll say book-service, just like this. So go ahead and hit enter. This might take a few seconds as it's gracefully stopping the container and the app inside it. So once this is done, you should see the name of the container that we just started. And just to give ourselves a blank slate to work with, we're also going to delete that container. So we'll say docker rm, and then we'll say book-service, just like this. And now that has deleted the container. So if we do docker container ls, you can see that we do not have any containers running. Okay, so now we need to start our container again. And this time, what we want to do is expose a port. So the command's going to be very similar to what we had to run the container in the first place. So we'll say docker run, then we'll say -d to start it in detached mode. And then we're going to add an additional flag, and it's going to be a -p flag. Then we'll add a space, and then we'll say 3000. Then we'll add a colon, and then we'll say 3000. So this -p flag is how we open up a port to the container. So on the right of the colon, we specified port 3000. So this is the port that our Express app is started on whenever the app starts inside the container. And on the left of the colon is the port that we want to bind our app port to. So just to keep things easier to follow, I have kept this as 3000 as well, but this could be any number you want. So if you change this to 4000, then that would bind the port 4000 to the port that the app is running on, which is 3000. So hopefully that makes sense, but we'll just keep these as 3000 so that it's easier to follow. So after we've done this, again, we'll just specify the name of our container. So we'll say --name, and then we'll call book-service, and then we'll add a space, and then we'll specify the image that we want to use, which is book-service. Okay, so once you've got this, go ahead and hit enter. And again, you're going to see the name or the ID of the container that was just started. So in here, if we do docker container ls, just like this, we can see this time we have the same stuff that we've seen before, but this time we have a port. So whenever we see an address here, that means that there is an open port to our container. So the way that it works on the local development environment is that Docker, when it binds the ports, is going to bind the host to be localhost. So what we could do now is do curl http://localhost, and we'll do port 3000 / and then we'll say books, which is the endpoint that the get request for the books array is on. So if you hit enter in here, you can see now that we're getting all the books back from the Express app that is started inside our container. So it's important to note that whenever you do expose a port on a Docker container, that it does bind to the host, which is normally on localhost. So if you have any other apps running locally on the same port on localhost, then you could potentially see an error. So just keep that in mind when you're developing with Docker containers locally. Okay, so now we have a container that's running. There are certain ways in which we can interact with the container. So for example, if we want to see the logs, what I could do is say docker space logs and then the name of the container, which in this case we've called book service. So if I hit enter here, you can see that the message that we display in our Express app whenever the app starts is being shown here. So any logs that you have in your application will be displayed anytime you run the docker logs command. So the other thing we can do is we can open a shell inside the container so that we can run commands directly inside the container. So to do this, we say docker exec. So the exec keyword means that we want to execute this command inside the container. Then we'll say -it, which means that we want to interact with the process inside the container in this terminal window that we are currently in. So it basically streams the results or streams the terminal from the container to this command window so that we can easily run our commands from here. So now all we have to do is we need to specify the container that we want to exec into, and then we'll say bash service, which is the name of the container, and then we'll say bash. So this will just open up a bash terminal, and just before you hit enter here, just make sure that you have the book service. Just make sure that you have the book service container started, or else this will fail. So go ahead and hit enter, and all being well, you should see something that looks like this appear. So what this is it confirms that we're now inside the container. So we're in the root, and this number after the @ symbol is the ID of the container. And then you'll also notice that we are in app folder. And again, the reason why we're in the app folder is because if we jump back to our Docker file inside the Explorer here, whenever we added the Docker file at the start, we specified the working directory as being /app. This is why this is the structure that we see. So in here, what we can do is run some commands. So if we say ls, which will print out the directory and file structure, you can see that we've got the code that's similar to what we see in the Explorer in our ID. So we have the package.json, we have the node modules, and then we have the source folder. And if we go into the source folder, we'll say cd src, and then we'll say ls again, just to print out the directory. You can see we have our index.js file. So this was just an example of what things look like within the container. This is an example of how to interact with a container, and it's also good to see the file structure inside the container, which hopefully looks familiar. So anytime you want to perform an action on a container, so you typically don't have to do this too often. The only time that you would need to do this is if you're trying to debug a container, just to check if there's some files missing or to check if everything's been added, and for general debugging. One of the biggest benefits of Docker containers is that it makes it easier to create a flexible microservices architecture that's running multiple containers at once. So if we're running tens of or even hundreds of Docker containers at once, this can be tricky to manage as they need to be able to communicate with each other, be start-stopped independently, and so on. So this is where container orchestration tools come into play, such as Docker-compose. So you might have heard of container orchestration systems such as Kubernetes, AWS, and Elastic Container Service, or even Google Cloud. So these all do a similar thing, and they make it really easy for us to manage our containers without having to worry about the low-level details of starting and stopping individual containers and setting up the network for each one, and so on. So we do this by creating a YAML file, which describes the microservices architecture that we want, and the container orchestration service will handle the rest. So even though we're going to use Docker Compose for this course, if you understand the concepts behind container orchestration, you will be able to apply your knowledge to any of the other container orchestration tools that you need to use in your career. Okay, so how do we set up Docker Compose to work with multiple containers? So the first thing we'll need to do is we'll have to define the services or the microservices that we want in our docker-compose.yaml file. So for each service that we want Docker Compose to start, we will define the images, any volumes, environment variables, open ports, etc. that are needed for that service to work. Once we have defined everything, Docker Compose will create the containers, a network for our containers to communicate in, any volumes needed, and so on. So after we've specified everything in the YAML, Docker Compose will literally go and parse that YAML and set everything up. And this is great for a development environment that closely mirrors staging and production environments. So even if your staging and production environment is using Kubernetes on AWS, for example, Docker Compose is still very useful for the local development, as it's much more lightweight and easier to set up. And it means you can run a lot of containers easily without the overhead of having to set up a Kubernetes infrastructure on your development machine. Okay, so to see this in action and to learn how to run multiple containers using Docker Compose, we will add a database to our book service where we will store all the available books. So to do this, we will use the official MongoDB Docker image, and we're going to call this container the book service DB. So this book service DB is going to be the name of the container, and inside this container, we will run the MongoDB image. So we're just doing this to make it easy to identify the different containers as we build out more services and containers throughout the course. So instead of creating our own image for the database, like we did for the book service, we will use an existing image which we can get from dockerhub. We will see how this works in the practical examples, and there's a lot of benefits to doing this. Once we have our images, we will create our Docker Compose file, which will start the containers and create a network for our containers, and which will also give our containers a unique IP address. Since the containers run on the same network, the book service over here can connect to the database using its service name that we defined in the Docker Compose YAML file. Since we will call our database container the book service DB, this is the service name that we use when we want to connect to the database that's running inside this container. So in our book service, whenever we set up the MongoDB connection, this is the connection string that we can use. And as you'll see in here, we have used the service name of the running container. So this works because Docker Compose provides built-in DNS service that resolves the service names to the container IP addresses. So even though the container will get a new IP when it's destroyed and recreated, the service name will be consistent, which is why this approach works. Okay, so now that we have some practice with creating images and starting Docker containers, what we will do is we will learn how to start multiple containers and how these containers can communicate with each other. So if you're following along in the terminal, what we want to do is get the code for the second part of this course. So in your terminal, make sure you're at the root level of the project, and then we'll say get checkout part 2. And if you have a look at the Explorer in the book service directory, there will be a few more folders added here. So one is the database and the other is the models. And if we jump into index.js, you can see we have this db start function in here. So what this code does that I've provided for you is instead of taking the books from the hard-coded array that we saw in part 1, this is going to try and connect to a MongoDB database. So if we have a look at the db start function down in here, it's going to try and connect to MongoDB. If successful, then it's going to initialize the database with some book data. So if we scroll up to the top, we can see that the book data is here, and it's the same structure as we've seen before. The only difference is this time the book service is going to try and fetch this data from our MongoDB database. So before it can do that, what we need to do is start a MongoDB database. And the best way to do this is to use the official MongoDB Docker image. So instead of having to go and install a MongoDB instance on our development machine, what we can do is start a container that has MongoDB in it. So where does this image come from? If you go to the browser and if you go to dockerhub.com, you can see at the top, I've just searched for MongoDB and it's brought me here. So this is the official Docker image that is provided by the MongoDB team. If we scroll down, you can see that there's some documentation here on how to use the image and different commands that we can run and different settings we can pass to the container and so on. So it's quite flexible and it's great for developers, as it means we don't have to build our own image based on a MongoDB instance. Instead, we can just use the existing one. So if we scroll to the top, you can see that there's a command here that tells us how to pull this image, or in other words, how to add the image to our local Docker instance that's running on our development machine. So anytime you want to use an image from dockerhub or anywhere else, you firstly have to pull it down. So it's similar to how you will pull some code from GitHub. We have to pull these images from dockerhub. So we'll jump back into our IDE then, and we're going to go into the terminal. So just open up a terminal again. And what you want to do is say docker pull mongo, just like this. And if you hit enter, you can see that it's going to use the latest tag, and it's going to get it from docker.io/library/mongo:\latest. So now that this has been pulled down, what we can do is check. So we can say docker image ls, just like this. And as you can see now, we have an extra image in our repository. So this is the local repository on our development machines, and now it has access to the MongoDB image. Okay, so before we try and start these things, we have to update our book service image so that it has the latest changes that we made to the code whenever we downloaded the part 2 code from source. So even though we checked out part 2 and we have the updated code in our ID, the image in our Docker repository still has the old version. So all we have to do is build a new image. So to do this, the command is the exact same as if we're building the image for the first time. We want to make sure we're in the book service directory. So we'll say td book-service, run the docker build command. So we'll say docker build -t as we want to tag the image. And then we'll say book-service : latest, just like this. And then add a space and add a dot to tell Docker that we want to use the dockerfile in the current directory, which is book service. So go ahead and hit enter. And as you can see, this is going to build the image again, and we can check that it worked by saying docker image ls. Okay, so now that we have a MongoDB image and a book service image that has the latest code in it, we could run commands individually to start a container for each of these images, but there is an easier way that Docker provides us to start multiple containers. We can do this by using what's called docker-compose. So docker-compose is a container orchestration system that lets us specify the services or the containers that we want to start in a YAML file, and Docker will handle the pulling of the images, the starting of the containers, and will set up a network for us so that the containers can communicate. So this is a nice convenient way for us to start many containers at once. So to see how this works, we're going to go into the Explorer, and in the root level of the project, so just outside of the book service folder, add a new file in here. So just right click and choose new file. And this is going to be called docker-compose.yaml, just like this, and hit enter. And as you'll see, we get this little Docker icon as well. So again, this is a well-known file. And if we jump into the YAML in here, this is where we specify the services, or in other words, the containers that we want to run. So the first thing we want to do is add a version in here. So we'll add a hashtag, and then we'll say version, add a colon, add some double quotes, and then we'll say 3.8. So this just specifies a version of the Docker Compose schema to use. And on a new line, we're going to say services, just like this. And then we'll add a tab, and then we'll say book-service, just like this. And then we'll add a colon. And this is how we specify a service that we want to run. So whenever we come to start this Docker Compose, we're going to see a container called book service appear in our Docker containers. So we'll take a new line in here, and we'll add a tab again. Then we'll say build, and then we'll say /book-service, just like this. So what this does is it tells Docker to build the code inside the book service folder and create an image from it. And what we can do is on a new line, say image, and then we'll say book-service, and we'll add a colon and say latest. So after Docker has finished building the image, it's going to tag the image with the latest tag, and it's going to call the image book service. And then we can take a new line, and if we want to, we can give the container a name. So we can say container name, and then we'll just call it book-service, just like this. On the next line, we're going to say ports and add a colon. And then we'll take a new line, add a tab, and then we'll add a dash, just like this. Then we'll add a space, and then we'll say port 3000 : 3000. So this is how we tell Docker Compose that we want to expose a port in our book service container so that we can access the Express app that's running inside the container from our host development machine. Okay, so next we're going to say networks, and this is going to be called app-network. So what this does is it's going to tell Docker Compose to create a network, which is an isolated network, and give it the name app network. So by specifying a network, it means that all the services or containers that are inside the app network can communicate with each other easily. So that gets handled by Docker Compose, and we don't have to do except specify the network and then add services to the network just like this. Okay, so on the next line, what we can do is specify environment variables. So in our book service, if we jump quickly into the code, so if you go to book service and if you go to source, if you go to the DB folder and into db.js, what we've got in here is the database connection logic. So if we scroll down until we see the DB start function, so it's in it and around line 22, you can see that the book service is going to try to connect to a database using the database URL environment variable that we pass in at runtime. So we can pass in these environment variables from our Docker Compose file, and they will get passed to the container, which will then get passed to our app, and then our app can use them in here. So if we jump back to our Docker Compose YAML, on the next line, just after networks, we're going to add environment, just like this. And then we can specify our key value pairs. So say database underscore URL, which is the name of the environment variable that the code expects. And the value, we'll say MongoDB : // and then we'll say book-service.db : 27017/books, just like this. So you're probably curious about this, where it comes from. So this book service DB is going to be a separate service, which we'll define in our Docker Compose in a minute. And because it's going to have the name of book service DB, and it's also going to be in the same network, we can specify endpoints using the service names, and Docker Compose will handle the service discovery for us. So this will become clear when we see it working. But for now, all you have to know is that services can connect to each other using the service names that we define. So after we specify the environment variables, we can say depends on _on, just like this. And we'll take a new line, add a tab, and then we'll say book-service-db. As it says, don't try and start the book service until the database, or in other words, the book service DB service has started. So this just prevents the app in book service from trying to connect to a database that hasn't started yet, because then the app will get an error because it failed to connect to the MongoDB server. So this is it for the book service, which is going to run the container that has our Express app in it. So now we just need to create a service that will start a container that has the MongoDB servers in it. So we'll take a new line, and at the very start of the line here, we'll define, and in here, we'll define the book service DB. So we'll say book-service-db, add a colon, and then we'll take a new line, and then we'll add a tab, and then we'll say image. It's going to be Mongo : playlist, just like this. So since we're specifying a pre-built existing image, we don't have to tell Docker Compose to go and build it. And on the next line, we can say container name, and then we'll call it book-service-db. And then what we can do in here is specify the networks. So we'll say networks, then we'll say app-network, just like this. So now our book service DB is on the same network as the book service. So that means these containers can talk to each other easily because they're on the same network. So after we specified a network, what we can do in here is say volumes, add a colon, and then we'll add in mongo-data, add a colon, and then add a slash, and then we'll say data, add a slash, and then we'll say DB. So what this does is it persists the data inside the database to file storage on disk on the host machine, which means that if this container restart or dies and has to be started again, then the data isn't lost because it's stored outside of the container. Okay, so now after we've defined our services, we have to specify the volumes and the network that we want Docker Compose to create. So even though we specified the volume that we want the service to use in here and the network that we want the service to use, we have to tell Docker Compose to explicitly create these. So to do this, we'll take a few new lines, and in here we'll say volumes, and then we'll say mongo-data, just like this. And we'll take a few new lines again, and I will say networks, and then we'll specify our app network. Then we'll add a driver, which is going to be bridge. So what driver bridge means is that it creates a private internal network on the host, allowing containers to communicate with each other while keeping those containers isolated from other containers that are not in the same network. And that's it for our Docker Compose file. So we specify two services, a book service that is going to start our Express server. And we've also specified a database for our Express server down here in its own container called book service DB, which is using the latest Mongo image. And then we specified our volumes and our networks. So now that we've created our Docker Compose file, all we have to do is start the Docker Compose stuff. So open a terminal, and I think what we'll do is we'll delete any existing containers we have just so we don't hit any issues there. So what we'll do is say docker stop book service, and then we will wait for this container to stop. And after we've stopped the container, we'll say docker rm for remove, and then we'll say book-service, just like this. And then we'll just double check that we don't have anything else. So we'll say docker container ls, and we have no running containers, so this is good. And now what we want to do is in the terminal, just make sure you're in the root directory. So we'll say cd, and once we're in the root directory, all we have to do is say docker-compose, then we'll say up, and then we'll say -d, and then we'll say --build. So what this is going to do is the docker compose up command is going to check the current directory for our docker-compose.yaml, and it's going to start all the services in detached mode, and it's going to build any images that it needs to build depending on the settings for a given service. So go ahead and hit enter, and as you can see, there was a bunch of stuff happened here. So if we scroll up and have a look from the start, you can see that it's building our book service, and we scroll down, you can see it says that there's 3 of 3 items running. So it created the book service container, it started the book service DB container, and it created our app network. Okay, so this is good. So now if we do docker container ls, you can see we now have 2 containers that Docker Compose has started for us. And on the port, you can see that it's exposed our book service on port 3000. So I think what we'll do is we'll go to the browser and have a look at this. So if you go to the browser, and in the URL bar, if you type localhost 3000/books, you can see now we've got response, which is all the data that is returned from our API. And because the data is coming from the MongoDB database, you can see that we have some IDs and stuff that was generated by the MongoDB database. Okay, cool. So this shows that our Docker Compose is working. So if we jump back to the code, hopefully you can see how it's much easier to use Docker Compose to start your services as opposed to starting everything manually. So what we will do next is we will add a second microservice, and we will learn how 2 microservices can communicate with each other using HTTP requests. Okay, so now we'll look at another example of how containers can communicate. Okay, so this time our loan service is going to make a request to the book service over here to get the detailed information about a given book. So this is common in microservices architecture and can be accomplished using HTTP requests in order to do this. So there are other methods for this, but for now we're just going to focus on HTTP as it's something that you're hopefully familiar with. So just like how we connected to the book service database using the service name in the previous part of the course, we can do the same thing here. So the loan service will make a HTTP GET request to the book service using its service name, which in this case is book service, which is the endpoint to the Express app that's running on /books inside of the book service container. It will then get a JSON response back, and it can do whatever it needs to with the data. Okay, so now we'll walk through how to do this, but if you want to try this yourself, feel free to pause the video here before continuing. Okay, so to start this next part, what we want to do is go into our IDE, and then we'll open up a terminal. And if you're following along, what you can do is make sure that you're at the top level of the project, and in here we'll do git checkout part 3. So what this is going to do is it's going to download the code for the loan service. So if we look in the Explorer on the left here, you should see we now have 2 services in here. So we have the book service that we have been working with so far, and then we also have this loan service. So what we're going to do is we're going to start the book service and the loan service outside of Docker in our IDE, just like we would if we were developing locally, just so we can see and test the functionality is working before we try to Dockerize all this stuff. So what we can do now is in the terminal, again, we'll say cd book-service, just like this, and then we'll say npm i for npm install. So this will just install the dependencies, and then we'll say npm start. Okay, so now that we have the loan service in our project, what we'll do is we will open up the folder in the Explorer, and then we'll go to source, and then we'll go to index.js. So we're just going to have a quick look at the code to help understand how it all works. So if we start from the top, so the main responsibility of the loan service is to store details about the loan. We have a loans array here, and we have 3 objects in here. Each one is going to represent a loan record. So if we take the first one, for example, we have a book ID, and we have the username of the person who checked out the book, and then we have the loan date. So you'll probably notice that we just store the book ID in here, and we don't store any more details about that book. That's because we are going to make a request to the book service for each of these items to get the book details, and we'll populate it in the loan service before we return a response. So if we scroll down again, you can see we've defined the book service endpoint. So this is where the loan service is going to try and make a fetch request to in order to get the book data from the book service. And then down in here, we've just specified an endpoint. So it's a get request to /loans. And then inside here, we do our fetch request. So we will try and get all the books from the book service. And after we've done that, we will parse the response into JSON, which will store in this books variable. And if we scroll down again, then all we're doing in here is for each of the loans in our loans array, what we're going to do is iterate over the loans. And for each loan, we're going to search the books array that we got back in the books response up here from the book service. And then we're just going to create a new object that has the loan details, and then we'll populate that object with the book details as well. And at the very end, we're going to return this response back to the caller. Okay, so what this will look like is if we jump to the browser, and if I do a request to localhost 3001 /loans. So what this will look like when we call our loans endpoint is we will get back an array with a structure that looks like this. So we're going to have 3 items in the array because there's 3 loans, and then for each of the loans we're going to populate this object with the book data, which comes from the book service. So hopefully this gives you an idea of how this works. So now what we'll do is we will add the loan service to our docker-compose file, and we will start everything up, and we'll see how it all works whenever it's containerized. Okay, so we'll jump back into our IDE. And if you open up the Explorer, you should see the docker-compose.yaml file that we added in part 2. If we open this up, you can see that we've got the services defined from the previous sections. So we have the book service DB, and then we also have a book service as well. And down at the very bottom, we have the volumes that persist the data, and then we've got the network as well. So what we want to do is define a new service in here called the loan service. So just underneath the book service code, what we'll do is take a few new lines. So it'll be around line 22 where the book service ends, and in here we'll say loan-service. So again, this is how we define a name for our service, just like this, and we'll add a space, and we'll take a new line in here, and we'll add a tab to make sure the indentation is correct, and then we'll say build, add a colon, and then we'll say /loan-service. So again, this tells Docker Compose that we want to build an image in this file location, and it will automatically try and find the Docker file in this folder in order to do that. And then we can specify an image name. So say image colon, and then we'll say loan-service, add a colon again, and then we can add a tag. So we'll just say latest. And next what we'll do is we'll specify the ports that we want to open. So we'll say ports, add a colon, and then we'll add a new line, and then add a tab again, and we'll add a dash. Then we'll say 3001 : 3001. So the loan service, the app, is going to start on port 3001. So we're just telling Docker Compose that we want to expose a port on this container on port 3001 so that we can access it outside of the Docker context on our host, or in other words, on our development machines. And we'll add a new line again, and we'll say networks, and we want to specify the network name as being app-network. So this is important because we want to make sure that all our services are inside the same network so that they can communicate with each other. So if we scroll up, you can see that we've also added app network to the book service as well. So this means these two things should be able to talk to each other without any problems. So just after the network property, we'll add an environment variable. So in here, I'm going to say book underscore service underscore URL, and this is going to be equal to http colon / and we'll say book dash service colon 3000 / books. This is also important, as in the code for the loan service, we have specified the book service URL as being an environment variable. So if we take a quick look at this again, if we go into the loan service, into source, into index.js, and see down in our endpoint / loans, which is a get request, we've defined a fetch request, and inside the fetch request, we've said that we want to go to the book service endpoint, which is up here, and we've said it comes from the environments variables. So this is how we pass environments variables from a Docker Compose file to our app. So whenever the Docker Compose starts the container, it's going to pass in the environment variables at that point, and then our Node.js app will have access to it. So this is why it's important. So we'll jump back into our docker-compose.yaml file here, and this should actually be service colon 3000 without the / books after it. So we'll just delete that. So your environment variable should look like this, and this value is going to get passed to our container when the container starts. And the other thing to note here is that we've used the name of the service as we have defined it in our Docker Compose file. So what I mean by that is we've said that we want to go to book dash service, and Docker is going to go and have a look up here under our services list, and it's going to try and find the name that matches that string. And then it knows, okay, so any requests to book dash service are going to point to this book service up here. Okay, so now that we've defined our loan service in the Docker Compose file, okay, so the last thing we'll do in here is we'll give our container a name, just so it's easy to identify what it is. So just after the image property up here, we'll say container underscore name, just like this, and then we'll say loan dash service. So sometimes if we don't specify a name, Docker Compose will create its own, and it can be pretty random. So it's good practice to name your container if you want it to be easily identifiable. So now that we've defined the loan service and the image that we want to build and use and some other stuff, all that's left to do is open a terminal. So go ahead and open a terminal and just make sure that you're in the top level of the project, as that's where the Docker Compose file is. And then we'll say docker-compose, and then we'll say up, and then we'll say -d, just like this. So this will run Docker Compose in detached mode, or in other words, in the background, using the dockercompose.yaml. So go ahead and hit enter. And as you can see, it's going to do a bunch of stuff here. And at the end, hopefully you see something like this. So it should be 4 green ticks, and you should see the book service. You should see the database for the book service, and you should see the loan service, as well as a network, which we called app network. So because we didn't specify an app network name, like we did for the containers, you can see that Docker Compose has added the name of the parent folder in here. So yeah, it's just made it a bit longer. So yeah, if you want, you can add a name in there. If you are not seeing something like this, you can try and delete any existing containers and images that you might have from the previous parts and try running your Docker Compose command again. Okay, so now that this is running, what we can do is say docker space container space ls. And if I zoom out, you can see that we have 3 containers running, and there is a port exposed for the book service and the loan service. So that means we should be able to access this in our browser. So if you open up a browser and go to localhost colon 3001, and then we'll say loans. So what we're going to do is hit the loan service, and hopefully we get the list of loans back with the books populated as well. And if we hit enter, you can see indeed we do. So what happened is the loan service did a request to the book service and populated everything into the response and returned it to us as JSON. So this shows things are working, because not only did we get a bunch of loans back from the loan service, we also got the details for a given book. And if you just want to test the book service as well, in the URL, what you can do is go to localhost colon 3000 /books. And as you can see, the book service is just going to return an array of books with some details in it. Okay, so hopefully from this you can see how 2 containers or 2 microservices can talk to each other using HTTP requests, and that it's easy to define and manage the endpoints for each of the microservices, as we simply just use the service name as defined in the YAML. Okay, so in this next section, what we're going to do is learn how to set up a reverse proxy by starting another Docker Compose service using Nginx, and we'll also take this opportunity to learn how to mount files to a container. Okay, so far we have just been working with two microservices, the book service and the loan service, but typically in this sort of setup, you would have a load balancer or a reverse proxy that is used to direct the traffic to the appropriate services. So I won't go too deep into this now, but the main advantages for this is that we can set up load balancing. So we could have multiple book service containers running, and we can configure Nginx to distribute the traffic across our containers. And there's also a big security factor here, as it means we can hide the internal addresses and ports of our services from any clients or any UI front ends that we might have, which makes it harder for attackers to get addresses and IPs and things like that, which is a good thing. There's other advantages here like authentication, caching, easier logging, etc. that we can set up in our Nginx configs, but we're not too concerned about that stuff right now. Nginx has an existing image we can use, so this will be similar to how we set up the MongoDB database in the previous section. We do, however, have to provide our own Nginx config so that Nginx knows how to direct traffic. This will be a good example of how to mount files within a container using Docker Compose. So again, before we jump into this, feel free to pause this part yourself if you want to. So before we jump into the Nginx and reverse proxy stuff, what we'll do is grab the starter code for the section, as that has the Nginx config in it. So we'll say git checkout, and then we'll say part-4, and just make sure you're in the top level of the project when you do this. And once you've checked out the branch, what you can do is go to the Explorer, and you should see the stuff that we have been working with so far. So at the book service and the loan service, there's no changes there, so those should be the same, and we haven't changed anything in the docker-compose.yaml as well. So this code is the same as from the previous section. The only difference is here is that we have this nginx.config file. So if we jump into this and expand the window a bit, it has the configuration that we want to add to the Nginx Docker container whenever we start it. So if you're not familiar with Nginx, don't worry too much about the finer details here. But basically all you need to know is that whenever we make a request to localhost/API/books, it's going to proxy that request, or in other words, it's going to forward on that request to the container that runs our book service. So again, it's going to use the DNS service discovery that Docker Compose automates for us to find the IP of the container that's running the book service, and it's going to pass it on to that container, and it will get handled by the Express app running inside the container. And if we scroll down, we're just going to do the same with the loan service. So if we make a request to localhost/API/loans, that request will get proxied to the loan service container that's running the loan service Express app, and that will handle this request as well. So that's all you need to know for this. We're not going to dive too deep into Nginx and stuff because that's out of the scope of this Docker course. Okay, so now what we need to do is we need to update our docker-compose.yaml file to include the Nginx image, and what we want to do is we want to make sure that our configuration gets mounted onto the container when the container starts. So let's see how to do this. If we jump into docker-compose.yaml, what we'll do is scroll to the very bottom of the services property here. And just after the loan service, what you want to do is we'll define a new service in here, and we're just going to call it Nginx, just so it's easy to identify and things. So what we want to do in here is we want to specify the image to use. So we'll say image, and this is going to be Nginx : and we'll say latest. So what this is going to do is it's going to tell Docker Compose that we want to use the latest Nginx image. And what's going to happen is it's going to first check the local Docker context to see if we have an image that matches this name. And since we don't, it will then go to dockerhub, which is the default repository that is configured. And it will then search for the Nginx image there, or this latest tag. So if we go to dockerhub and if we search for Nginx, just like this, you can see we've got the official Docker image here. And if we click into it, you can see that this is the image that it will find and it will pull down. So even though we don't have the image locally, we don't need to pull the image manually, as Docker Compose is smart enough to go and try and find it itself. So this is good. Okay, so in our code, what we'll do is we'll scroll down again, and after we specified an image, what we'll do is specify a container name, and we'll just call this Nginx, again, just so it's easy to identify. And then what we want to do in here is we want to specify the port. So we'll say ports, and then we'll say 80:80. So this is the default port that websites use, so it means we don't have to actually specify the port when we try to use localhost. And after we've done that, now we can specify the volumes. So volumes are files and folders that we want to copy to the container whenever it starts. So this is good, as we want to copy our Nginx config. So we'll say volumes, and in here you can see that it's given us the template that we can use to define how this works. So we'll type it out first, and I'll explain how it works after. So we'll say ./nginx.conf, then we'll add a colon, and then we'll add a slash again, and then we'll say ect nginx/nginx.conf. Okay, so this might be pretty confusing, but if we open up the Explorer, and I'll just try and keep these two open. So what we're saying here is we're specifying the file that we want to copy from the host. In other words, this Nginx config over here. And then on the right of the colon, we're specifying where we want to copy that file to. So this is a convention by Nginx. So Nginx is going to go to this folder inside the container, and it's going to apply the configuration that it finds in here. So this is why we want to put it there. So this path on the left is relative. So since our Docker Compose file is at the same level as our Nginx config file, then that's why we say / just like this. So whenever the container starts, this file will get copied over to the container, and this is the one Nginx will use. Okay, good. So now we specified the volume, and we will say networks, and we'll say app network. So again, this is so that all the containers on the same network can communicate with each other. This is important since Nginx container will be directing traffic to our other services that are running in Docker Compose. Okay, good. So now the next thing we want to specify is we want to specify the depends on property. So what this means is that we can specify a list of services that must be started before Docker Compose tries to start the Nginx service. So in here, we can say book-service, add a new line, and we'll add a dash again, and then we'll say loan-service, just like this. So this means that the Nginx container isn't going to start until the book service and the loan service have started, which is ideal because we want to make sure that these services have started before Nginx tries to send traffic towards them. Okay, so that's pretty much it. So now we've defined our Nginx reverse proxy service. So we can save this, and all that's left to do now is to start Docker Compose again and see how it all works. So it's a good idea to stop any existing containers and stuff that you have, just so that we don't see any conflicts. So what you can do is say docker-compose and then say down. And this is going to stop any existing containers that might be started from any of the previous steps. And so once it's stopped, what we can do now is say docker-compose up-d, and just make sure you're in the top level directory, or the directory that has your Docker Compose file in it, and go ahead and hit enter. And as you can see, it's saying up here that it's pulling the Nginx image. So I was pulling that from dockerhub, and if we scroll down, we can see a bunch of green ticks, which is good. And at the very bottom, you can see the number of things that were started. So we've started 5 things. We started the network, we started the book service DB, we started the loan service DB, we started the book service, and we've started Nginx. So hopefully at this point, you're starting to see how Docker Compose is pretty powerful in terms of starting, in terms of building images, pulling images, and starting all the different containers that we need. As even though we could start all these things outside of Docker Compose by just running the Docker commands ourselves, this is much more efficient, and it gives us lots of other nice things as well. So what we'll do now is we'll test our proxy. So if you open up a browser, and what we'll do now is we'll go to localhost, then we'll say /. So we don't have to specify a port here because Nginx runs on port 80, which is the default. So we'll say / and then we'll say API, and then we'll say /loans. And if you hit enter, you should see the same response that we've seen previously when we accessed the loan service directly. This time we're just going through our Nginx reverse proxy. So this is good. It shows everything's working, but we do have one thing that we want to tidy up. So in the browser, if you go to localhost colon 3001/loans, you can see we can still access the loan service directly by bypassing the reverse proxy. So this isn't ideal, as ideally we want all the traffic to go through the reverse proxy, as it's better for things like security and speed and caching and things like that. So what we can do is jump into our code again, and we'll say docker-compose down, just like this. So this will stop the Docker Compose containers cleanly. And after this is done, what we can do is we can close our terminal, and then we're going to go into our docker-compose.yaml, and we scroll up to the top where we've defined our book service. We have told Docker Compose that we want to expose a port here. So what we'll do is just comment this out. You can delete it if you want, but just in case you want to undo it, you can just add comments like this. And then we'll scroll down until we see the loan service, and we'll just comment out the ports here as well, just like this. So what we've done now is we've said that these containers can communicate with each other inside of the Docker context if they are on the same network, but the host can no longer access these containers directly. So remember, we said that containers are isolated by default. So by taking out the port property, then we're saying that we cannot access this container outside of the app network, which runs inside the Docker context. So now if we scroll down again, we're going to keep the port for Nginx open, as we do want to be able to access the Nginx container, as that is going to direct all the traffic. So we'll keep port 80 open on that container. So now if we open up our terminal again, and if we say docker-compose up, say -d, just like this, and if you hit enter, it's going to start our Docker Compose again. And it was a bit quicker this time because it's cached some of the images and the Docker layers. And now what we want to do is we'll jump back to the browser again, and we'll try to call the loan service directly. So we'll say localhost colon 3001/loans. And as you can see, it's taking us time to load, and eventually we see unable to connect. So this is good. So now we can access our service directly. And if we go to localhost/API/loans and hit enter, you can see we can now access the loan service, but this time we have to go through the API gateway. So this is typically how it's done in production environments. All the traffic to microservices will be handled and managed by something like Nginx, which does the load balancing and reverse proxying. So hopefully you see the benefits of this, and hopefully you're able to see how Docker containers run in isolated environments, and how we use the networks property in the Docker Compose file so that containers can talk to each other. Okay, so up until now, we have been building and hosting our images within the Docker context of our development machines. This is fine for development, but since we want to deploy and run our Docker Compose setup in the cloud, we need to host our images where cloud services can access them. So there are many container registries, but the one we will use is dockerhub. This is a popular option, and it works well with our local Docker setup, so it's a good one to use. So to do this, there's only a few steps really. We create an account on dockerhub, and then we log in from our development machine to our dockerhub account. Then we will build the image as usual, which will create a Docker image on our local development machine. And after we've done this, we can use the docker push command to push the image, or to upload the image to our dockerhub account, where it will create a new repository for this image. So we will see how to do this in the upcoming section. So if you go to hub.docker.com, you can check the description for the links as well. It should bring you to this page, and this is the same place where we can search for images. But what we want to do now is go to the top right where it says sign up, and what you want to do is sign up. So just fill out the form, and after you've signed up, it should bring you to the dashboard back on dockerhub. And if you choose repositories at the top, it will bring you to the page where you can see all your Docker images. So currently there's nothing here, but that's okay. So what we're going to do now is we're going to build and add our images to our dockerhub account. So to do this, we'll jump back into our ID, and we're going to open up a terminal. And in here, the first thing we need to do is we need to connect to the dockerhub account that we just created so that we can push images to it. So to do this, in the terminal, we'll say docker space login, just like this, and it should ask you for your username and password. So go ahead and enter those, and all being well, it should say login succeeded at the end. So now our local dev machine is authenticated against our dockerhub account. So anytime we run docker push commands, we will be allowed to do so. Okay, so now that we've logged in, what we can do is build our images and push them to dockerhub. So what we'll do is we'll say cd book-service, just like this, just to make sure we're in the book service directory. And in here, we're going to say docker space build -t and add a space. Now at this point, you want to add your Docker username that you signed up with. So in this case for me, it's JS Chris, and I'll say slash, and I'll say book-service, and then I'm going to add a tag. So for the tag, we can tag it as anything we want. So we'll say v1 and make sure to add a dot after the command to specify that we want the current directory. So what this is going to do is, because we tagged the image with our username at the start, this tells Docker where to push the image to. So this is a convention, and by specifying the repo, Docker knows where it should send the image to. So if we hit enter here, it should build an image for us. Now if we do docker image ls, just like this, there's a few images here, but as you can see, we've got the book service that's been tagged with the JS Chris repository, and it's got the tag v1 as well. So the image is built. All we have to do is push this. So we'll say docker push, and we'll say JS Chris. So again, make sure that you're using your own username in here and not mine, and do slash, and then say book-service, add a colon, and then we'll specify the tag that we want to push, and then we'll say v1. So this is going to find this image, and it's going to push it to our Docker Hub account, all being well. So go ahead and hit enter, and as you can see, it's pushing all the different layers and stuff. So this might take a bit of time, and then at the end you should see a bunch of stuff that looks like this, which basically means that it worked. So if we jump back to our Docker Hub account, and if you go to repositories tab again, and if you do a refresh on the browser, you should see that your image has appeared, and it should be called book service. And if we click into it, we can scroll down and we can see that the image is tagged with the version 1. So this is good, it shows it's working. So then we'll go back to the code, and again in the terminal, what we'll do is we'll say cd, and we'll change the directory to be the loan service this time. And then we can do docker build -t to tag it, and we'll say JS Chris, or your username, and we'll say slash, and we'll say loan-service, and then we'll say v1 as well, and then we'll add a dot at the end here just to make sure we're in the current directory when it tries to build it. So go ahead and hit enter, and this will build the image for the loan service. And again, just like before, we'll do docker push, and then we'll do JS Chris, or your username, slash loan-service, colon v1, and then we'll hit enter, and this will push the image to the repository. And when it's done, you should see these messages at the bottom. And what you can do is double check by going to the browser and scrolling up to the repositories tab again. And if you go to the repositories tab, you should have 2 images. Okay, so this is good. Now we have a Docker image for each of our services. Now it means whenever we want to host our Docker Compose on the cloud somewhere, then regardless of the cloud service that we use, whether it's DigitalOcean or Amazon or Azure, then all of those services will be able to access our images to pull down onto their servers and to start the containers for us. So this is why we must do this. Now what we need to do is we need to update our Docker Compose file and tell it to pull the images from Docker Hub instead of our local repository. So what we'll do is jump into the code again, and in our IDE, we'll go to the Explorer and we'll open docker-compose.yaml. And in here, we want to scroll to the top, and we'll scroll down until we see book service. So currently we've configured the book service to build the Docker image every time we start Docker Compose, and then to use this built image when it starts the container inside the Docker Compose cluster. So to tell it to pull the image from the Docker Hub repository, all we have to do is comment out the build step and update the image step. So just after the image tag, after the colon, what you want to do is specify your brand name. So in this case, it's JS Chris for me, but make sure you're adding your own thing in here. And then we'll just update the tag as well to be v1. So this is the name of the image and the tag that we have just pushed to Docker Hub. So now, whenever we do Docker Compose up, it's going to pull the image from Docker Hub instead of trying to build it. So that's the only change we have to make for the book service, and we just need to do the same for the loan service. So we'll scroll down, and again, we'll just comment out the build step in here, just like this, and then we'll update the image. So we'll say username slash, and then we'll just keep the loan service like this, and then we'll change the tag at the end here to be v1. Okay, so that's our changes to our docker-compose.yaml. And now to test this on our dev machines before we try and deploy it to DigitalOcean, we'll just open up a terminal, and we want to make sure we're in the top level of the project where our Docker Compose file is, and then we'll say docker compose up, -d and hit enter. So this is going to work the same as before. It's going to check if all the images that we specified for each of the services exist in the Docker Compose file. Because we built the loan service and the book service recently, then they will be, as well as the Nginx image and the MongoDB image. And it started everything in the app network up here. So again, if we jump back to the browser and we'll just test that everything still works by going to localhost/API/loans, and it does. So we're able to get a response back from the loan service, which also calls the book service. Okay, so this is good. We've now got a Docker Compose file that pulls all the images that it needs to start all the containers from dockerhub. So what we'll do next is we'll set up a DigitalOcean account, and we'll set up a server, and we will see how to deploy our Docker Compose setup to the DigitalOcean server. Okay, so the last thing we will do in this course is deploy to DigitalOcean. At the start of the course, we talked about how one of the key benefits of Docker is that we can run containers anywhere that has Docker installed. So deploying our application to a cloud server is a good way to see this benefit in action. So if you want to take advantage of some free credits that you can use so that you don't have to pay for any of your droplets, you can check the link in the description and you'll get some free credits that you can use for this. So what you want to do once you're on DigitalOcean is go to sign up and then just choose your sign up method. Once you've entered your details, you can go ahead and fill out this questionnaire that it gives you. Doesn't really matter too much the answers that you put in, and then go ahead and hit submit. Now at this point, it is going to ask you for your card details, and the reason it does this is because DigitalOcean is just trying to verify who you are. So this is just to stop bots and things like that from getting access to the droplets. As you can say here that you're only billed on the usage and the services that you use, and because you will hopefully have used the link in the description to get some free credits, then you shouldn't be charged for your credit card unless you leave stuff running for months. So go ahead and fill out your details, and then at the bottom choose save and sign up. Okay, so once you've signed up, you should land on the DigitalOcean dashboard, which looks like this. And there's a bunch of stuff you can do from here. So you can start up some databases, you can start a load balancer and servers and things like that. So there's quite a lot that you can do. But what we want to do is we want to go to the droplets option on the left hand side. So what a droplet is that it's a server that we can use to deploy our Docker Compose to. So this server doesn't have very much on it. It's quite a basic Linux server. So we'll have to install a few things, but not very much. So on the right hand side here, if you choose create droplet and go ahead and choose your region. So it's a good idea to choose a region which is close to you so that the performance is a bit faster. And once you've done this, scroll down and it's going to ask us for an image. So just keep the default selected here and we have to choose an image. So if you choose the marketplace option, and it should bring up a bunch of pre-built images. So because the droplet doesn't have anything installed on it, what we can do is we can choose a template which will install some software onto our droplet automatically without us having to do too much ourselves. So over here, there's a Docker one. If you don't see it, just go ahead and search for Docker and then choose the latest one. Just make sure it's on the Ubuntu package. So go ahead and choose this. And then at the very bottom, just make sure that you have the basic plan selected. And if we scroll down under CPU options, if you choose regular and then just choose the cheapest one, which is about $6 a month. And if we scroll down, the next thing you want to add is an authentication method. So what this is it lets us connect to our cloud hosted droplet from our development machines using SSH keys or using a password. So go ahead and choose whichever option you're comfortable with. I do recommend you set up an SSH key because that's a lot more secure than a password is. But if you're not sure on how to set up an SSH key, if you choose new SSH key, it'll give you some instructions here that you can run that will give you a key and then you just paste it in here. So choose whatever option you're comfortable with when it comes to authentication. And after you've done this, you can go ahead and choose create droplet down here. This will take a few minutes to start, but what's going to happen now is it's going to start a server for us that has Docker installed on it. Okay, so now we've got a droplet configured. What we can do is connect to this from the terminal in our IDE, and then we can start adding the Docker Compose stuff. So what we want to do first is we want to copy this IP. So if you hover over it and choose copy, and then we're going to jump back into the IDE and open up a terminal. So in here, this is where we connect to our droplet, and we can copy some of the files we need to the droplet from our project, and we can install Docker Compose. So to connect to it, so if you're using SSH, you can follow along with me here. It'll be a slightly different approach for username and password. So in here, we'll say SSH, and then we'll say root, and we'll say @ and then we're going to paste in the IP of our droplet, just like this. And then if we hit enter, it's going to say some stuff about authenticity of host, blah, blah, blah. Go ahead and hit yes, this is fine because we control the server. So you can say yes down here in the terminal and hit enter, and it will add the IP to the list of safe hosts that we can connect to. So we scroll up again, you can see it's printed out a bunch of stuff here. So it's just some stuff about your droplet and things if you're interested. And there's some messages for us as well. So it's installed Docker and it's configured, and it's also installed Docker Compose as well. So this is good. So we don't have to actually install anything else because it's all come out of the box for us. So just to make sure it's running, what we can do is say docker -v, and you can see that it gives a version, so this shows that Docker is running. Okay, so now we can connect to our server and Docker's running. We'll type exit, and this will bring us back to our terminal in the project outside of the droplet. Okay, so now what we need to do is we need to copy our Docker Compose file to our droplet so that we can run the Docker commands on our droplet to start our app. So in here, what you want to do is make sure that you're at the top level of the project, and we're going to say scp, so this is the copy command. Then we're going to say docker-compose.yaml, then we'll add a space, and then we'll add in the user, so it's root, and we'll say @ and then what you want to do here is paste the IP of your droplet in there, just like this, then add a colon, then we'll say / and we'll say root. So what this is going to do is it's going to copy the Docker Compose file to our server, which lives here, into the root directory, and go ahead and hit enter, and all being well, you should see the transfer data here. So it's at 100% and the speed and so on, and the file that was sent over. So next, what we want to do is we also want to copy our custom Nginx config. So that's this Nginx config file here as well. So we've copied the Docker Compose file, and we just have to do the same for our config for Nginx. So easiest thing to do is in the terminal is if you press the up key, it will bring us the command that we just typed. And if you use the arrow keys to go back, and we'll just delete the docker-compose.yaml file, and instead we'll say nginx.conf, just like this. And then if you hit enter, it should copy it as well. And now what we can do is we can access our droplet again. So we'll say ssh root @ and then paste your IP, just like this, and hit enter. And as you can see, the terminal will change a bit, and this will tell us that we are now on the DigitalOcean droplet, and we can type commands down in here. So in here, if you type ls, this will print out the files and folders in the current directory. And as you can see, we have our docker-compose.yaml file, and then we've got our Nginx configuration in here as well. Okay, so now there's only one thing left to do, and this is where the magic happens. So we'll say docker-compose, then we'll say up -d. So since we're in the same directory as the Docker Compose file, then this is the Docker Compose file that is going to use by default. So you can go ahead and hit enter here. Oh, and it says Docker Compose not found, so we'll have to install it. Okay, so we'll say, let's copy this apt install Docker Compose command. So we'll say apt install Docker Compose, and then for any options that you see, just go ahead and hit yes and hit enter, and this might take a while. Okay, so after that's done, you'll see a whole bunch of stuff. So I think what we can do is say docker-compose, and then we'll say -v, and this looks like it installed okay. So from here, what we can do is try this again. So we'll say docker-compose up -d, and there we go. So as you can see, it's doing a lot of stuff that we have seen so far in the course in our own machines. So this is exactly the same. It's going to pull all the images that it needs. It's going to create all the infrastructure, so the network, the app network that we need, the persistent volume that we need for our database, and all the other images. So if we scroll down, we can see it's pulling the Mongo database, it's pulled our book service, and it's still doing some more stuff. So it looks like we have a few more services to wait for. So eventually you should see it's pulling Nginx, and that's the last one. So now it's creating the containers, and that's all done. So now what we can do is say docker container ls. So hopefully in here you can see that we've got our containers started, and we've also got our Nginx port has been exposed as well. Okay, so now what we can do is we can try and access this in the browser. So if you go back to the browser, and what you want to do is open a new tab, and then and in here, paste in the IP of your DigitalOcean droplet, and then we'll add a slash, and then we'll say API, add a slash again, and it will say loans. And then if you hit enter, you should see that we now have a response back from the loan service that is hosted on DigitalOcean. We have the book details as well. So that means the loan service is able to talk to the book service and get the details, and everything is going through the reverse proxy. And since we're able to get the books back, it means that the book service is able to talk to the database container as well. So all the little bits of our Docker Compose infrastructure are communicating successfully. Okay, so now that we've seen how Docker Compose works on a cloud server, it's a good idea to destroy the resources that we were practicing with, so that we're not having to pay for things that we're not using. So if you go back to DigitalOcean, what I recommend is if you choose your droplet and if you choose the options on the right hand side, you can see there's an option to destroy. So this will completely destroy the droplet and all the stuff on it. So that just means that you're not having to pay for it anymore. The disadvantage is that you will lose the Docker Compose file and the Nginx config that we copied to it. If you decide to create a new droplet, you'll have to copy those things again. So it's up to you, but I do highly recommend that you destroy the droplet when you're finished with it, as opposed to leaving it on. Okay, so that brings us to the end of the course. I hope you learned a lot about Docker and seen the benefits of how it can be used to deploy applications quite easily. If you like this video, feel free to drop a comment down below and let me know what you'd like to see next. Otherwise, don't forget to subscribe for more cloud and DevOps videos. Thanks for watching. I'll see you in the next one.